is I do record every lesson here. It is in the microphone. You will be able to hear yourself if you speak loudly. I always do a dual display. What that means is I'm going to write on the right-hand side. For those people that can't see past my hair, you will be able to see when it gets to the other side. I stole somebody's pen here. Okay. All right, here we go. So our title today is MHF4U Review of Functions. Today is September the 5th, 2017. Okay. Lucas. Do you remember what a function was from last year? Now, before you say nobody knows what a function is, the whole course is called functions. I don't know if you know this, okay? So I'm giving you a stalling time. Remember what a function was?
No.
Like if I were to say, what's a function? Pass. Ty, any idea? You guys all took functions, didn't you? Somebody help them out. What's a function? Go ahead. No. Uh-oh. One last guess and then I'll take over.
Okay, like variables, like functions when you using the equations that kind of substitute like numbers for letters.
Sort of, okay. I'm going to go a little bit more detail. Function has one output for each input. Okay, so this is a function. Can somebody tell me what that graph looks like if you have to guess? Going back to grade 10. Opens up to anybody here. What does that look like? Good? So what an equation, what's the equation for parabola? Close? Close. Y equals x squared. This is like x squared. That's a function. Now the reason for that is because if I were to sub in x equals 2, you only get one value. So 4. If I sub in x equals negative 2, you get 4. But you only sub in one thing. This is an example of not a function. Okay? Can someone recall why from grade 11? And I used to teach grade 11, so I know you were taught this. And I hope you were taught this. Go ahead, Glenn. Very good. There's something called a vertical line test. So if I go like this, that means there are two y values here. Therefore, not a function. Okay, so if this comes back. So does anyone have an idea what that equation would be, the sideways problem? I think you saw this last year, didn't you? Just the graph inverses? Oh, yeah. This would be like the square root of x. And it's plus or minus square root of x, right? So the square root of 25, if you remember, has positive 5 and negative 5. So that's how that goes. Is this looking familiar to anybody here from last year? Yeah. Good. Two people nodding their heads. That's good. Okay. If I say domain, can somebody tell me what domain means, please? Actually, I'm going to pick on somebody here, Jake. Jake, since you know you raised your hand, I'm going to pick on you again. Do you remember what domain means from last year? You said that. Go ahead.
How far function stretches?
Good. Is it for x? On which axis? On which axis?
X.
Very good. So this is going to be the span of values on the x-axis. Okay, this is the way that I'm going to write it. Now then I'll show the way your textbook will write it. Does that look familiar to anybody from last year? Do you guys do your domains like that? One person's nodding their head. Okay, good. Okay, so yes, two people nodding their head. If you haven't, can somebody please tell me, I'm going to pick on Evan if you don't mind. What does that mean in English? Pass, that's okay. Someone want to help me? What does that mean in English? It's up to anybody here that's feeling confident. Yeah, go ahead.
X can be any real value, so such that -3 is smaller than x and smaller than 4, and x can be any real value.
Okay? That's what it means in English. That's what that means in English. X is between -3 and 4. So it doesn't hit -3, it doesn't hit 4. Is it starting to come back a
Is
little
that
bit?
a less than sign or like more sign?
This is just like a line.
No,
This just,
like,
oh, this is less than and less than. Yeah, less than, less than. So basically it says you're talking about X, that's the variable you're talking about. X is between -3 and 4, and X is a real number. What's a real number? We're not picked on yet. Paula, what's a real number mean?
Pass.
Everyone's passing here today. Yeah, go ahead.
a real number is one that is in like decimals.
Yeah, it is decimals. Any positive or negative whole number or decimal is a real number. So basically any number you've seen, except for the square root of a negative number. Okay?
Then what's an imaginary number?
Imaginary number is the square root of a negative. So what this looks like on a graph would be a straight line. Now let me just write this the way your textbook would write it as. Your textbook writes this. Okay? So let me see if I can do this. Those two mean the same thing. Okay? So curly bracket 3, 4, that's your domain. That means the same as X is between -3 and 4. I will not write it like that, but your textbook often will, so that means that X is between -3 and 4. Yeah?
So can you write it like that?
Yes, you may. Yes, you may. But just in class, I won't. The other thing I'm going to write here is the other example. So if I were to write it like this, Andy, since you switched spots, I'm going to pick on you right now. What does that mean, please? That number right there, what's the difference between that and above? Paul, you want to help her?
Like, so they're less than or equal to?
Less than or equal to. So for this one here, it doesn't quite hit 3, -3, but it comes close. And it doesn't quite hit 4. This one it does. The way your textbook will write this is this. This is why I don't like this, because it's confusing. Square brackets means it hits the number, and round brackets means it comes close but doesn't touch it. All right. Finally, I'm going to do one more, and then we'll move on to some examples here. This one will be in green. Okay, if I were just to write, that's supposed to be a squiggly bracket. If I were just to write that on the board, x/xer, that is a domain. Taryn, is that right, Taryn? Okay, Taryn, what do you think that means in English if it just says x/xer? No?
No, pass.
Okay. Zach, go ahead.
X can equal any number?
X is any number. Any real number, right? Okay. Now, the way that the textbook does this, it looks like this. Can somebody be brave? Gabby, tell me what those funky symbols with those sideways 8s mean, you know? You know, all I want to pass them all coming back to you, actually. Yeah, you can't pass her over. Maddie, go ahead. It means infinity. What does infinity mean?
Limitless.
Limitless. It's the biggest number possible. I'm going to make a few jokes here to just stay with me here for a sec. My daughter knows what infinity already, because every day I see her, she goes, Daddy, I love you infinity. And I go, oh, that's nice, Ava. I go, Ava, I love you infinity plus 1. Does that make sense mathematically? No, it doesn't make sense. Infinity is the biggest number possible. You can't get bigger than it. I first discovered infinity when I was about 3 years old. I was watching Sesame Street and the Count was on. Anyone know the Count from Sesame Street? Oh, nobody watches Sesame Street anymore?
That's the count.
There's a guy named the Count. He goes 1 2 and he just loves to count things. So there was a little girl in the show and he said, you know, what's the biggest number you can think of? She goes 38, and he goes add 1 to it, 39. And I said, that's awesome. So then I, going in my head, oh, that's a good number. Mommy, what's the biggest number after 99? 100, okay. Mommy, what's the biggest number after 999? 1,000, okay. And I said, there's got to be something, it's got to stop somewhere, right? Like you're thinking as a kid. So infinity is where it stops, where you can't add anything to it. It's the biggest conceptual number. It's not an actual number like 9.83 zillion. It just happens to be the biggest concept. Yeah, biggest concept, okay? So anyway, that's what it looks like through domain and range. I'm sorry, I feel awful embarrassing like that, but the phone's driving me insane, I'm sorry. Okay, there's one other thing we do with functions, and this is some algebra with functions here. Next example 1. We're going to say f of x equals 3x minus 2 squared plus 4. Okay, what equation is, what is that I just wrote on the board? That is a what? Go ahead.
That's, no, wait, what was it? I actually can't, I know, can't.
Well, that's function notation, right? So instead of y, it's the same as y is. Let's say I said y equals. What form is that for an equation? It's called what? Uh-oh. Vertex form, thank you. Very okay, good. I was worried. I wanted to pass for every question. That's good, okay. Vertex form. So what I'm going to ask now, I'm going to say letter A. It's going to say find f of 3. Okay. Now, you guys have done this since you were in grade 9. Okay, it looks frightening in grade 11 when they made you do this. So somebody tell me, please, Caleb, what does f of 3 mean? Do you know what that means? Yeah. So all it means is everybody's seen x in the original equation or subbing a 3. Okay, so it's like subbing in there. So I'm going to pick on somebody named Magenta to sub in 3 everywhere she sees an x. Go ahead, please. Yeah, say it out, please. Go ahead.
So f of 3
Yeah,
equals 3
yeah,
bracket 3 minus 2.
yeah. Great. Okay, if I'm doing some good algebra here, I'm going up to Madison here. Madison, using your bed math, what do we do first here, please?
Yeah.
Go ahead. So 3 minus 2 is 1. Okay. You got off easy. Livia, can you please solve this one? What's the next thing we do?
1 squared.
Which is just 1, which is good. What do we do next? Keep going.
Multiply by 3.
Good. So 3 plus 4. And that's 7. So what this has told us, I'm going to point on the graph called 3, 7. Okay, right? That's what we just figured out. Okay, so that's why you did function stuff last year. Now, the other reason, anyone in this school can look to anybody, what else is functions useful for? Why do we care about functions? What can we do with them? And what's the whole purpose of last year? This is bad. Nobody's going to help. Well, they're basis for transformations. That's the main thing that you did function notation for. Anything you can do with one function, you do with any type. So I could put a sine graph up there, I could put up anything. But transformation, it's an easy thing to do using function notation. So I'm going to do this right here, transformation. And then I'm going to hit pause in the video, and then you guys are going to give me the answer. Now, before I set you off on this, okay, because this is some great algebra, okay? That looks scary. What does the x minus 3 inside the brackets, Charles, tell me to do? What does that after the x minus 3 tell me to do?
That the unknown number needs to be subtracted by 3.
Sort of like that. We're thinking way too deep though. If you think of what we did here, f of 3, we just change everywhere I see an x, change with a 3. So if it's x minus 3, you're right, it doesn't have to be, so everywhere I see an x, I'm just going to put an x minus 3. Okay? This 2 on the outside means whatever my function is at the very end, I just times it by 2. Okay? So I'll even give you the first line because I'm kind. The x minus 3 is the x minus 3, and the 2 is the 2. You guys have seen this a little bit last year, I hope. It's an algebra. Somebody tell me you guys did algebra like this? One person? Good, that's good. Okay, so now your guys' job is to FOIL. Okay? So what I do is do bed maths, and simplify the inside bracket first, and FOIL it out and give me a new equation. Okay? You can do it, have confidence in yourselves. I'm going to pause the video, and when I unpause it, then we'll... Yes.